The technology that I am going to talk about today is Feather Farms, a AI-based mobile application for poultry counting and disease screening. The lead inventor is Dr. Rashmi Nair and the organization is MIT Arts Design and Technology University, Pune. The core challenge that poultry farmers face is bird counting and disease monitoring. Monitoring today is manual, subjective and non-continuous. It has limitations of count inaccuracy. It is impossible to monitor thousands of birds 24/7. It is time consuming and error prone, and this affects feeding and management decisions. Disease detection today is mainly based on clinical diagnosis by veterinarians and other lab tests, and therefore early disease detection is also a challenge since early symptoms are hard to detect and cannot be done at a farmer level. On a global scale, 69 billion chickens are raised for meat production every year, and poultry diseases result in over 10 billion in annual global economic losses. The manual counting increases labor costs, results in inefficient feed use, inventory mismatches, and late disease detection also leads to rapid spread and higher mortality, increased treatment costs, and causes significant production and financial losses. So AI in poultry science presents an opportunity for optimizing production, enhancing animal welfare, and improving disease management. The existing methods are manual monitoring, a cuckoo-based app which is a deep learning feces detection system, Phytobiotics Chicken Checker, which is a smartphone based poop analysis, and Pondus Oflox AI, which is a camera based monitoring system. The market size, global AI in poultry disease market size is valued at US 402 million in 2024 and growing at a CAGR of 20.5% from the period of 2026 to 2035. The major players are Phytobiotics, Poultry App, Livestockify, Flocks, Avian Tech, Birdsight, etc. What are the limitations of the current methods? The manual monitoring is time consuming, error prone with no real time detection. Phytobiotics Chicken Checker is only feces monitoring, no counting and no continuous monitoring. The Cuckoo app is a prototype stage. It is in a controlled environment with no real time monitoring, and the Pondus or the Flocks AI is expensive, applicable to large farms with no disease detection with a complex setup. So this technology is mobile application based using Flutter Dart for cross-platform compatibility. The database is a Firebase Firestore used for storing and managing application data. As you can see, you can add a daily record. There is a interface for bird counting, and it will show you the predicted bird counts. There are farm alerts for poop analysis, bird counts and current risk. There is a scan for poop and analysis and training and learning. How it will work? There will be record digitalization which will enable farmers to record daily records directly in the app, which will replace the traditional paper logs or manual registered, and you will have more structured digital records. It will capture parameters like feed consumption, water, mortality, bird health observations. The other is the bird counting ResNet 50 based counting app, which is using a reliable deep convolution neural network, and it is suitable for detecting birds at various angles, mixed lighting, overlapping birds, and it has been trained on 2000 plus images captured at different time points, and it is capable of real-time counting from camera feed with high accuracy. The poop detection system, which is a mobile VIT model-based system, which processes images as patches and gives highly accurate detection. It is trained on 8000 plus poop images using Kaggle database, and it can detect early signs of disease like Newcastle, coccidiosis and Salmonella. How the models were trained? As you can see, for the counting data set, cameras were installed in a real poultry farm. Images were captured at different angles and different time points. They were extracted, the frames were extracted from the videos and manually annotated to mark each bird, and then they were used to train the ResNet 50 based counting model. The poultry data image set consisted of 8000 plus fecal images from Kaggle. Images were captured using a mobile application. So on an actual farm, you would have a smart system which would do 24/7 monitoring. It would capture the data, analyze the data, give early warning signs, send alerts through real-time notification and guide actions. So from early detection to smart decisions. The hardware cost for a 3000 square feet farm would be around 25,000 rupees, and the software app cost would be 3,500 for a 45-day cycle. Validation studies were done for the counting data set. They used 2000 plus annotated bird frames at various angles and various lighting conditions and overlapping bird and crowding scenarios, and they were validated using actual manual counting, and it was found to have a accuracy of almost 95%. For the image database, they have taken 8000 plus images from Kaggle, and this was used for Salmonella 2000 images, Newcastle's almost 500, and healthy 2000 images. And for validating the data, they took 50 images of all 4 sets and cross-checked it for accuracy. Please note that these are lacking the clinical validation, that has still not been done, but the accuracy that they got on MobileNet V2 was almost 96%, and on Convix Next Tiny it was 97% accuracy. So the value proposition is continuous monitoring, no blind spots, flock level visibility which leads to better decisions, automation, reducing labor dependency, actionable alerts, faster response, and early detection which will prevent losses. If you see the differentiation matrix which compares farm feathers with manual monitoring and RIFT, you will see that it matches high accuracy and maintaining ease of implementation, and which the poultry farms can use to scale. The technology is at TRL level 4 or 5. The working prototype has been validated on 944 plus farm frames, and for the poop data detection on more than 8000 plus images. A patent has been filed with a priority date of 2025 in India, and there is one publication. The next step, they are seeking collaboration with poultry industry farmer partners for pilot testing, validation under real farm conditions, supporting large-scale deployment and commercialization, and also collaborations to customize for poultry integrator, government schemes, corporate farming, regional customizations. They are also open to licensing. The team consists of Dr. Rashmi Nair, who is the lead inventor and associate professor at MIT Arts Design and Technology. The other team members are Digvijay Sakore, who is a developer and lead AI engineer, Om Kare for data collection and field operations, and Vedashri Patil for data annotation and data set preparation. Other mentors are Dr. Mohit Dubey, Pro Vice Chancellor, Dr. Pratibha Livingstone, Associate Professor, and Dr. Renu Vyas, who is also Associate Professor at MIT Art Design and Technology. And for more details, you can reach out to us at these coordinates.